Hello. In this video, I'm going to explain problem 7 from the 2014 F equals MA contest. In this problem, we have a 1 meter long stick with uniform density that is allowed to rotate at a point 30 centimeters from its end. And then we are told that the stick is balanced when a 50-gram mass is placed on the stick 20 centimeters from the same end. So this is 20 centimeters. And then up to the pivot is 30 centimeters. The entire length is 1 meter, so that's 100 centimeters. And we're asked to find the mass of the stick. Well, since we are told that this rod is free to rotate around the pivot, this is clearly going to be a problem about balancing torques. So here we have the mass, 50 grams, and since this distance is 20, so I'm going to use grams and centimeters in all of these calculations. So, and from now, since all of these numbers are given, it may actually be easier to work without units or without variables, and instead to just work with the numbers. That's usually not the case, and I usually advise against that. But in this kind of problem, it tends to be easier. So since the distance from the one end to the pivot is 30, and the distance of the mass to the end is 20, then the distance of the mass to the pivot is 10. And now the gravitational, so that we're going to have a gravitational force, and that gravitational force, so I'm going to call that Fg1, is going to be the gravitational acceleration, that's little g, not for grams, times our mass, which is 50 grams. Or actually, why not? 50 grams. Let's just leave it like that. And then the gravitational force on the rod will act everywhere, but we can just treat it as a single gravitational force acting at the center of mass. And that is going to be a total of 50 centimeters from either end. So we're going to get 20 centimeters from the pivot, and so that will be Fg2, which will be G times the mass of this pivot, which I'll call M. Or, excuse me, the mass of the entire rod. And so now, the net torque is 0, and we have two sources of torque, one from the gravitational force on the rod, and then one from the extra mass. So remember that torque is equal to the cross product of the radius vector, or meaning the radius vector from the pivot, and the force. In this case, since the force is perpendicular to the radius vector, we can just, and since everything is acting in a single plane, we don't need to worry about cross products. We can just worry about the magnitudes and ask whether the torque is clockwise or counterclockwise. And so what we see is that the force of gravity on the rod will be, or the torque exerted from that force will be G times M times 20 centimeters. And then we subtract the torque from the force acting on the mass, the 50-gram mass. So it will be G times 50 grams times 10 centimeters, and that must equal 0. Now, one thing is that, what if this rod were at an angle? Well, then that means that the torques would still be at the same angle. So we could add a sine theta, but that doesn't really matter. Or cosine theta. Sorry, sine theta. And from this, we can just get some cancellation and see that M is 1/2 times 50 grams, is 25 grams. In general, the mass will just be 1/2 the mass of the mass, or this extra mass, which here is 50 grams, so the mass of the rod is 25 grams. And so that's the answer.